Hey everyone, in this video what I want to do is I want to show you how to set up your forecast. I'm going to show you exactly how I would approach a forecast, and hopefully by watching this video, even if you have to watch it a couple times to take notes or either just to watch it full on through, my hope is that you'll see it enough times that you'll be able to feel comfortable in setting up your forecast. So right now I'm showing you my screen. I have nothing loaded. I have not seen anything. So this is a purely raw forecast. But I am going to pull up a few tabs first. The first one I'm going to pull up is Pivotal Weather. I already have it loaded. Remember, click on Models. And what I really want you to do is I want you to start off with the GFS, and I'll explain why in a second. Under the Zoom tab, you're going to click Continental US, and you're going to click the Continental tab on the left. You are then going to select North America. Okay. Now, what you're going to do, under animation, where it says single image, you're going to click that and you're going to click forecast loop. So this way you can loop the image instead of clicking all the individual timestamps that's shown on the left. You can either roll through it or you can use the less than or greater than key on your keyboard. I like that version better. Now what you're going to do is you're going to go to scroll down, upper air dynamics, and you're going to go to 500 millibar height and vorticity. Click that. And this is where you want to start your forecast off. So this shows 500 millibars, or 10,000 feet up in the atmosphere, and it also shows vorticity, the energy that spawns low pressure systems. This is a great place to start off. Normally in the real world, how you would start off a forecast is by going off of the previous forecaster's forecast discussion. And why is that? Well, number one, it gives you a bias and it already gives you a platform to work off of. And number two, you always want to piggyback off the previous forecaster. The reason why you want to piggyback off the previous forecaster is because, especially in the private industry, it doesn't matter if it's in the private industry, in the TV sector, or the National Weather Service, which is the government sector, you always or try to keep your forecasts as consistent as possible, meaning you don't want to be flip-flopping. You don't want to tell your entity, your customers, or the general public it's going to be perfectly sunny one day and then it's going to be a full-blown snowstorm. And then a day later, actually, it's just going to be sunny again. No, it's not. It's going to be a full-blown snowstorm. So you like to keep things as consistent as possible. However, you're not real meteorologists. So you're going to create your forecast from scratch. And I'm going to show you how to do it from scratch. And when I was learning meteorology back in college, I also had to create my forecasts from scratch. And this was exactly how I did it. Now, when you look at the upper level map and you look at the vorticity map, why is this important and why is this a good place to start? Well, number one, you can see the entire view of North America. You can see where the jet stream is. You can see where all the little vorticities are, all the little vortices, all the pieces of energy in the atmosphere that may play an important role to you in your forecast down the road. So this is really where the party's at. Think of it like this. When you log onto Facebook at the end of the day, or whenever you log into Facebook, you're really just scrolling through your news feed. When you scroll through your news feed, you find something interesting and then you click on it, you look at it further, and then you go on to the next thing. So think of 500 millibar vorticity as in you're opening up Facebook or your favorite social media platform and you're really just scrolling, you're just scanning, you're just looking at what's going on. I like to say this is where the party's at because all these vortices will spawn low pressure systems, and if you can understand how these move and you can understand how the jet stream works, then you're really going to have an easier time. You can also form a bias. Remember when we talked about troughs and ridges? When you see a trough, you know that a location is going to be colder and have more or be more susceptible to low pressure systems, whereas a ridge, you're going to be under a more warmer trend and you're going to have more dry weather, sunny days due to high pressure. So when you look at 500 millibars, it paints a great picture of the atmosphere. It paints a great picture of the jet stream. You can see how the jet stream is flowing, and you can see all the vortices for when you are looking for any kind of low pressure systems that may cause any type of precipitation in your forecast. So just by looking at this alone, what do we see? You see that the jet stream here, it's pretty flat. I don't really see any kind of big troughs or ridges or anything like that. Now if I scroll to the right a little bit, here we have a big area of high pressure. Here is a huge ridge out over the Atlantic, and this is the Azorian High. Remember that the Azorian High and the Bermuda High, they're the same thing, except it's February as I'm recording this, and so the Azorian High is more concentrated over the Azores. Remember, this is one of our mid-level high pressure systems. Back towards the left-hand side, here you have a big trough and a quite powerful area of low pressure over the Pacific Ocean. But for the rest of the United States, here, it's pretty flat. And so we don't really have any kind of big, waves of energy or big storms or big circulations that really kind of grab our attention. So in this video, what I'm going to do is I'm just going to make a forecast for Boston. You can make a forecast for any location that you want, but I'm just going to focus on the Boston area because that's where I am from. I'm from Massachusetts. And so as I move through time here, I'm going to scroll up a little bit so you can see the timestamp. Here it says 500 millibar heights, relative vorticity, and you can see valid Thursday, February 28th, 2019 at 18 Zulu, okay? So this is daylight savings time. So 18 Zulu is 2 o'clock in the afternoon. So when we look at this, right, let's move forward in time, and I'm just going to use the less than or greater than arrows. What do I notice? Well, here for Boston, right up in here through Massachusetts, okay, I don't really see any kind of big areas or big waves or, really anything too concerning. Here, this is the polar vortex way up here, always constantly spinning, and because it's wintertime, because it is February, almost March, it's still relatively cold. The polar vortex is always there, it just retreats way further into the Arctic Circle during the summertime. But anyways, back to the forecast. Here, like I said, for Friday, Friday seems pretty dry. Now this is Friday, 0 Zulu for March 1st. So what is that? That's 7 o'clock Thursday night, which is basically the time that I'm recording this. So here, it's pretty dry, and I don't necessarily see anything that's really too concerning. The only thing is that here, right, we have a little wave. You see where all the light oranges or almost yellows are. And here you have a little surface trough, or you have a little trough in general. So I'm just going to highlight this real quick, just so you can see. Remember, if you cut the trough in half, right? I don't know why this is very light. I'm going to undo this. Hold on. Okay. Remember, if you cut the trough in half, right, where's our area of low pressure? Our area of low pressure would be on the right-hand side. So we should have an area of low pressure developing in this area, and on the left-hand side, we should have high pressure, okay? Just by cutting that trough in half. It's a very, very weak little trough. It's a very weak little wave, but I do see something that could impact the Boston area for Friday, Saturday time frame. So as I move forward, I'm going to close this out. As I move forward in time, I look, okay, and here, right, it doesn't necessarily develop into much, but here's Friday, right, 9Z. That's about 4 o'clock in the morning, Eastern Standard Time. And here I just have a little weak little wave. It doesn't necessarily look like it's going to be much, but it could be something to watch. So I'll just keep that in mind, and I'll write that down that I might want to watch something in the early morning time frame on Friday. Okay. Now remember that these vortices don't always spawn low pressure systems. Sometimes they just spawn little waves. Sometimes they just indicate fronts moving by, little pockets of moisture that don't necessarily accumulate to much.